All right, guys, so in the last activity, we were doing arithmetic sequence and series. In this activity, we're going to be doing what's called a geometric sequence and series. Arithmetic, we actually had what was called a common difference, which is a D. What we did there is we took two consecutive terms, we subtracted the second one from the first one to find our D, and we had to do it more than once to make sure it was a common difference and not just a unique difference. In geometric, we're actually going to be multiplying to get to our next term. So here, I already have a geometric sequence I've listed here. Now remember, a sequence is a list of numbers. A series is when we start to add the numbers together that are in the sequence. So here, this sequence I have is 5, 10, 20, 40, and 80. So we're multiplying by 2 to get to the next term. An easy way to think about that would be the recursive formula. We would start with some given number, and we're just going to multiply the previous number by our common ratio. In this case, we have to figure out how to do our common ratio. To find the common ratio, it's going to be the same process as with arithmetic, but instead of subtracting, we're now going to divide. So we're going to take two consecutive terms, the 10 and the 5. We're going to take the second term, which is 10. We are going to divide it by 5, and that gives me 2. Well, we have to do this more than once, so we're going to pick two other consecutive terms. Let's do 80 and 40. We're going to take the second term, 80, divide it by 40, and when we simplify this, we get 2. Now here, this is going to be our common ratio, and in our formula, it's going to be denoted by R. So our R is 2. A sub 1 is still the same thing. A sub 1 is our first term in our sequence. In this case, it's 5. In a geometric, we have our equations. We have our nth term equation, which is a sub n equals a sub 1 times r to the n minus 1. So if I wanted to write the nth term equation for this, I have my a sub 1 and I have my r right here. So all I simply do is just plug it in. I say a sub n equals 5 times my r, which is 2, to the n minus 1. Now, later on, possibly in college, they're going to make you take it to the zero term where they'll have to break down the exponents. I'm okay with just leaving it like this for right now. I really am more concerned that you can actually just come up with the term equation, because as we get further into this, and we're going to start doing a series, and we have to write it in a sigma notation, this will be the formula. This right here will be the formula that we'll use in our sigma notation. Okay, so let's use the same sequence, and now let's make it into a series. Well, to make it into a series, all we're going to do is just simply add the terms. We're going to do 5 plus 10 plus 20 plus 40 plus 80. Now, the first thing I want to ask you to do is we're going to go ahead and just write this into sigma notation. So the first thing we need to do is we need to just go ahead and write our sigma. You're going to pick a letter. In this case, I'm going to use K. And you will always start with 1 when you're writing sigma. We're going to count the number of terms. In this case, as we're looking at, we have 1, 2, 3, 4, 5. That will be my top number. My equation here is my nth term equation that we found on the previous slide right here. So it is 5 times 2 to the n minus 1. But make sure you match up your letters. So we will do 5 times 2. I'm going to change my n to k because that is the letter that I chose, k minus 1, and you're done. Now, I know we're using scientific calculators, and graphing calculators, you can actually just type this right in and get an answer. But we have formulas that would allow us to do these answers. The formula for our geometric series is going to be my sum to my nth term is going to be my a sub 1, 1 minus r to the power of n, divided by 1 minus r. So we already know the a sub 1. Now if it's given to you in sigma notation, your r is going to be whatever the exponent's on, and your a sub 1 will be the number preceding the base with an exponent. So when we just look here, sorry about that, guys. The bell started to ring right in the middle of the video. So we know our a sub 1. Our a sub 1 is 5, and my r is 2. So we just plug it into our equation. We're going to do 5 times 1 minus 2 to the nth power. My n, I forgot to tell you guys, is my top number right here. So to the 5th power, 1 minus 2. When we do this math, we'll end up with 5 times negative 31 over negative 1, which ends up being negative 155 over negative 1, which is just 155. When in fact, if you do add 5 plus 10 plus 20 plus 40 plus 80, doing it that way, you will get 155. I will in class give you things. Let's say we want to calculate, I want you to do S sub, I want you to add the first 30 terms of the sequence. Well, this, you don't really want to write it all out. In the next video, I'm going to talk about a special scenario that happens with geometric sequence and geometric series. When you're adding, we're going to talk about how to add to infinity and what you have to look for to make sure you can add to infinity, because a special situation must happen.